What's up everyone, in this video you will learn what is and how to use AWS Lambda. It's split into three parts. First, simple explanation. Second, practical example how to create and use it. And third, some more advanced configurations. Let's go. In simple terms, Lambda is just a function that's hosted in a serverless way. We can easily connect it with databases, API gateways, queues, and many more. Let's say I created this node.js function, square, which takes any number and returns it squared. And now my goal is to make it available for my clients. In the classic approach, I would have to create HTTP server, for example using Express.js or Nest.js, buy small server instance for a month or year, host it there, and typically I would have to pay for the whole period. But instead I can just take this function, put it into Lambda, and I don't have to worry about any servers and any setup. It will just work, and AWS will bill me only for runtime. So if there is no traffic, the service costs exactly $0. You can ask, what's the big deal here if I can buy small server for probably $2? So Lambda is super scalable and super convenient. It's gonna work for one client as good as for 1 million clients. You don't have to worry about load balancing, instance spawning, proxies, networking, and so on. It just works out of the box. Let's create an example. I assume you already have AWS account. You can create it for free and it offers very generous free tier, so you can learn and create hobby projects for free. Open your console, search for Lambda, click create function. You can use blueprint or upload container image, but for now let's create it from scratch. Put some name, I'll name it maybe Square Factory. We have a bunch of runtimes available, but I'll stick with Node 22. The rest you can leave as it is. ARM versus x86, I'll explain that in the last part of the video. Click create. Real-world apps can consist of thousands of lambdas, so we want to automate deployment with, for example, a CDK or SLS tools, but for simplicity, AWS has a nice VS Code simulator here where I can experiment with my lambda, so let's implement a simple square function. I have an event param here as an argument by default. That's wrapper for my params. Keep in mind we can't change the name of the function because AWS is looking for it in the runtime. I can simply assign params like this, event.something. Okay, let me quickly write this. Update the response, save it. Now I can test trigger it passing my number variable. And I am getting the response. Cool. Let's go a step further and allow my argument to be URL query so I can use it outside of the AWS console. First, go to the config tab, create public URL. If you create one, be careful because everyone with this link can access your resources, trigger this function. Now go back to the code and little change to get access to the query. Let me change that. Save it once again. And check this out. Now I can put number as a query. And I get a nice JSON response just like that. Of course, it's dummy function, but as I said at the beginning, there is a bunch of integrations available out of the box. Let's talk a little bit about some settings. Which architecture type should you choose? There is ARM and x86. ARM is around 20% cheaper per gigabyte seconds because you get billed by memory and runtime. Quote from official AWS blog, we see the benefits of migrating from x86 to ARM based. No matter what Lambda you have, you'll probably gain performance while saving on cost. The sole exception is memory heavy workloads. If your Lambda function is doing memory heavy work, such as reading huge data files and operating on them in memory, and is latency sensitive, then you may be better off sticking with x86 based lambdas. So which one is better? Short answer, for 90% cases it's ARM. What's more, here I can set the timeout. RAM memory, you can manually set value between 122 megabytes to 10 gigabytes. The more memory you allocate, the execution gonna be more expensive, but that's not always the case, because more powerful environment executes faster, so it's gonna decrease overall runtime. You have to find the sweet spot for your use case. There is AWS Lambda Power Tuning app that can help you to optimize your Lambda functions. It's not worth if you spend a couple bucks on AWS, but for big apps you can save tons of money with proper tuning. Let's quickly overview other popular tabs. Triggers, as the name suggests, they are services/resources that triggers the function. Previously we did it manually, but usually that's not the case. Permissions, super important. Here I can set which resources can be used with my Lambda. For this case, I have just CloudWatch actions for creating the logs. In the real world app, there's a bunch of them, DBs, storages, queues, and so on. I recommend you to learn how to properly apply EAM auth and always be careful what and who has access to any of your resources. Destinations. For example, say you have a Lambda that asynchronously uploads videos to S3 and you can configure on success send details to an event bridge bus that full video chunk was sent or whatever comes to your mind. And variables, pretty self-explanatory. State machines is also a very cool mechanism. It's a topic for separate video, but in short, it can orchestrate, apply error handling, retry requests to your Lambda functions. It's perfect for chaining some sequences. Okay, that's it for today. I recommend you to just play around with this. Thanks for watching, subscribe for more, and hopefully see you soon.